Hello there, it's Jay here from Jay's Vintage Junk. Excuse me. And today I thought we'd have a look at this. What we've got here, this is a Gamma Dosemeter type 2601/W. It's an XMOD unit. It's basically it's a dose rate meter. It's a Geiger counter. I picked this thing up years and years ago, and I was down in the cellar a little bit earlier today, and I spotted it on a shelf, and I thought, oh, I'll dig it out and see if we can do anything with it. I don't know what. I don't think there's any. This thing actually works. I can't remember why it ended up just being dumped in the cellar, to be honest. I do have another Geiger counter which I thought I'd show you, which does work. I actually raked this out of a skip on a site I was working on. It had been dumped in a skip. This does work. It has its tube, its little Geiger Muller tubes in this handheld probe, and if we switch it on, I've got a this is an old gyro compass out of an old aircraft, and if we bring the probe, we can see it's not terribly radioactive, but oh, well, it's fairly radioactive, I suppose. So at least we have a source of radiation to test this, if we can indeed get it to work. I'll just put that out of the way, and let's see if we can get inside this thing. The only thing that concerns me about this is it does rattle, which could mean that the tube's been smashed inside it. I mean, we could possibly get a new tube for it, find a tube that we can make work in it. I don't have any, but I know they are available online. Let's see if we can get in here. So I don't do a lot with Geiger counters and things like that, but I do find them interesting. And I've got a few little radioactive sources like that. They are mostly, I think, have I got any, I might have some glass somewhere that's uranium coloured or something like that. Uranium coloured. And so I've got a few aircraft dials. So I've got a few things to use as radiation sources. Right, we're in. We've got some very gummy looking battery contacts in here, but hopefully, let me just give that a bit of a dust out. Well, where's my bin gun? Yuck. Now that's a little bit cleaner. I've got some D-size batteries here. I think this uses 2 D-size batteries. I don't think they're anything special. Oh, well, that one's not very good. Look at that. A bit on the dented side. Let's just see if that still works. It's not leaked at all. It's just dear me. These are brand new in the packet as well. I don't know if that's happened. These batteries are alright. Well, yeah, it's showing 1.6 volts. Let's test the other one just for completion. That's showing 1.6 volts, so we have got 2 indeed good new batteries. Put that one in there. I'll put that one in there. Make sure that's off. Let's try a battery check. So battery check seems to work. This thing isn't as dead as I thought it was. Let's try switching it on. Oh, it's come right round like that. Is it measuring that? I'll bring this. Oop. It's dropping back down. Like I said, I don't know what this thing's doing. Like I said, I'm really not. Don't even know whether the tube in this is sensitive to the radiation that this is giving out. Is it gamma that these give out? In which case it should be okay. Let's drop down to dropping sort of 0.5 there. Seems to be dropping even more. I don't know whether this thing's working or it's just it flattened its batteries. I'll put it on battery check and nothing's happening at all. Oh, there we go. Most odd. Shall we go inside it? I've really read up on this thing before I started making this video, but I was just curious to see what, if anything, it would actually do. We need to go inside it anyway, because we need to investigate what's rattling around in there. And I'm sure it's going to be interesting. Perhaps this thing doesn't click like my other Geiger counter does. Oops. We're in. Yep. Oh wow. Now that is awesome. For anyone that's into like proper vintage electronics, take a look at that. Now that really is quite cool. Let's see, hopefully you can see it well enough there. Yeah, it looks very well made. It's all point-to-point wire. This isn't a printed circuit. It's basically little posts, and it's all done with wire wrap. So basically, you've got all these pins, and then there's the component legs are wrapped round these pins, and the joining wires are all wrapped round these pins, and then they're soldered after that. This is like really, really solid construction. It is rather nice actually. There's some corrosion in here. There's looks like it might have been wet at some point. There's lots of corrosion around here. The transistors are actually pushed through holes drilled in the circuit board there. Like I said, it's not a printed circuit board, but it is a circuit board. And the transistors are actually like pushed through holes drilled in it to keep them in the correct places. It seems to be really, really nicely made. Now, I still haven't discovered, unfortunately, what's making the rattling noise on it. I have a horrible feeling it may actually be the tube, which is this thing here. Let's try disconnecting it and see if it does actually rattle. If it does, I think we're going to be looking to see if we can find a replacement for it. Looks quite a nice piece of equipment. This is quite an interesting instrument. I love, probably like 1970s. I'm sure this is 1970s era. Could be slightly earlier. I doubt it's 1980s. I suppose if I look online I'll be able to find out the exact age of it. There we go, that's free. I have a horrible feeling this is what's going to be rattling. want to come out either. So, there we are. Right now, out you come. So what I will do, I'll snip it free and leave a little bit of the insulation on the leg I cut off so I know where to solder them back. But oh, actually it doesn't seem to rattle. It does seem to have a bit of corrosion. And can you open these things? Are you meant to open them, or will I damage it opening it? I don't know. Some horrible corrosion around this screw, so we better have a look, see what's gone on. And there's the tube. It does appear to be intact. Yeah, seems intact. It seems as though it has definitely been wet though. Just to say it's intact doesn't say it's any good, but I'm trying to put the wrong screw back in there. Oops. One screw in. So it looks like the rattle isn't from the tube anyway. I was really expecting that to be broken. For those playing along at home, 20th Century Tronics type B6TS number 7549/80. Max operating voltage and no one's filled it in. Made in England. I don't know what my chances of actually finding a replacement for that will be actually. Let's give this thing a shake. I'm really interested to see what's making that rattling noise. We can't be doing this thing any good. Is it the meter there? It very well could be. That could cause a problem. The question is, how do we get into it? I think we'll have to take that board off to get to the meter movement. That can be the only place I can really think where there's going to be anything now that could be causing that rattle. Some of these screws are rather rusty as well. So I definitely have a feeling that this thing has seen water at some point. What's coming free? There don't seem to be a lot of battery corrosion in the battery compartment, so I don't think the corrosion's come from battery leakage. This one's going to pose a problem because this one looks to be very corroded. Oh, there we go. Testament to the build quality, I think, that. The question is whether it's affected any of these capacitors. In fact, these Pesley 100 UF here, they look very, very crusty. There's white deposits all over that side. It could just be a reaction to the aluminium. So look at the seal side, and the seal side doesn't look so hot either. So I think we may want to look about possibly replacing them two capacitors there. I think this may turn into a bit of a bigger restoration video actually. Let's move. Oh, look at the quality of this though. There you can see the underside. There's the high voltage transformer to provide the high voltage needed to activate the Geiger tubes there. And this meter looks very, very heavy duty as well, really. Let's see if we can find some pliers or something. Get these nuts off. And we'll remember black left, purple right. Ah, we've got a date as well, fantastic. 15th of October 1975, so I was right for the mid-1970s unit. And from the style of the components used, I was thinking probably it would have to be very, very late 1960s and into the early to mid-1970s, so we've got a reasonable date there. It could obviously be a replacement meter. But I think, judging by the rest of the components, and we may have a date on some of these capacitors when we look at them. Maybe it'll date it a bit more, but for now, that's looking that's fairly good guess from what I'm seeing, that it's mid 1970s. This thing. My other unit, I think, is mid 1980s. Right, now we need to, I'm hoping, if I release this ring, then the meter should drop out from the front. At least that's the plan. Let's free that off and see. No, I should be so lucky. Is it going to want me to do some more dismantling? I think it is. Let's try taking this aluminium plate out here. There we go. Let's give us a little bit more access. I think we're going to have to take this whole. Right, I think we'll have to take the control knob off the front here. In fact, we're going to do a really good restoration on this thing, you know. At least it gives us an opportunity to clean all the gunk out of this case and make the case nice as well. So this is definitely going to be part one of probably a two-part restoration of this thing. Let's at least in this part get this mechanism out and see if we can trace what's rattling in there. So I weren't expecting to quite go to this length on this thing, but that's what happens when you start these things. Right, let's see about getting. There we are. That's that ring off. And yeah, that's what is causing the problems. So let's get this out of the way for now. And let's have a look we pull these bits up together so we don't lose anything. Oops. And let us, all the sealing rings falling apart on it, let's see if we can get inside it. Now, getting inside these things can be fun. Sometimes if you take off all the nuts on the back cover then slides off them. I'm not holding out much hope on this one. We will see. Note on this that it's just going to loosen off the studs. So it looks like we're going to have to unbend all around there. Let's see how much work this is going to be. Oh, this is going to be easy enough. It should be easy enough to bend back as well after when we're finished. We've hopefully sorted its issues out. And hopefully we can just do this on 3 sides and we'll be able to pop this bezel off. Do one more side. There we go. That's off. Ah, here we go. Oh dear, that's not good. Right. So it looks like this thing sustained a bit of an impact. And all this that's fallen out here, this is what actually holds the mechanism there in position. What screws it to the back. Yeah, that's quite a bit of damage, that's going to be a pain. Right, let's see what we can do to fix this. First thing I'm going to do is I'm going to desolder these 2 wires, remembering red positive is that way. That's the negative off. That's positive off. Move that out of the way. Right. Well, I think our mechanism's actually still okay. We'll have to take that front plate off, I think, to be able to actually repair this thing properly. And what we've got, if we're looking there, we can see where that's meant to be mounted on them two studs in there, and all we've got is this this pile of plastic and a couple of nuts. So I'm going to have to figure out possibly some araldite or something, whether I can glue this back together and remake them studs and mount that back in there. So I don't think I'm going to be able to do that on camera actually, so I think you're going to have to join me in a minute when I've managed to possibly glue these bits back together. So see you very, very, very shortly. Okay, I managed to get it back together. I must freely admit I ended up cheating. I just could not get them bits to stick back together. Basically, they're just too broke up to do anything with. So what I did instead is, this is that tape that I use for sticking the fronts back on 48K Spectrums. And I stuck a couple of pieces of that onto the back of the aluminium faceplate, and basically, because that is screwed to the whole mechanism, and it's actually screwed there quite well, and it's a fairly thick piece of aluminium, I was able to use that as the bracket and stick the whole thing down to the front of the plastic in there, and as you can see, it doesn't rattle anymore. The movement is nice and free to move. Like I said, there's no chance now of any of them little bits rattling around and getting jammed in the mechanism. And I managed to get it all back together and crimp back the aluminium bezel there. I wouldn't like to have to open it again because I'm sure that would start to break up, but we have got the mechanism, as I said there, back together. So let's have a look at putting that back in the actual the unit for now. This may all come back out again yet. I'm still not 100% decided. In fact, yeah, sod it. Let's do this. Let's strip all the aluminium out of here, and we're going to I'm going to actually clean the outer casing. I'm not going to retrobite it. I'm not going to make it look pristine and new. It is rather badly yellowed, but at least what I am going to do is put it in the bath and give it a damn good scrub and get as much of the muck and rubbish as I possibly can off it. So we need to desolder these that go to the battery connections. So we'll have to remember yellow on the left hand side, black on the right hand side. There we go. So that is the yeah, it just looks nasty in there. Let's take that out. All this can get a really good clean up in the bath, and hopefully we can get as much of the muck and rubbish. So there's nothing we can do about the yellowing on it. It should be that colour, but obviously it's aged quite badly. But oh, that's quite nice as well. At least this shows us what everything is, what all the transistors and what have you are in the EHT drive. That's, as I was saying, that transformer. Overload trip. It's got all sorts in there, and a lot of rust, as you can see. So that can go off into the bath and get a scrub in, and we'll see how clean we can get that. We have the meter movement as best as we can now. I think the next thing we really want to do is we'll probably replace some of these capacitors because they're not looking too healthy. These should be okay. These are low value. It's more the electrolytics here that I'm more concerned about because they have some deposits on the sides of them. So definitely those two are going to have to go. There's two 2.2 UFs there, which yeah, I think I'll probably change them. 1.5 UF there, yeah, we'll probably end up changing that. That's a 0.39 UF. We may change that if I've got one in stock. We've got there 47U. That should be okay. We can test these anyway. Got some fantastic mullered transistors there. What, AO10s? Yeah, two AO10 transistors there. These are those electrolytics. I'm not sure whether those are electrolytics or not, but well, anyway, we can test them and we can see what state they're in. That should be okay. Wire wound resistor again, that should be okay. That should be okay as well. On the back, again, we've got large electrolytic there. That's got a date on it. It's got a 24. No, I can't see it. Oops, don't want to break that. That's bad. Shouldn't drop them over. We'll probably end up changing that 470 UF. I'm sure I've got some of them in stock. We'll give it a test anyway. But yeah, I think we'll leave that for another video. I've waffled on long enough on this anyway. I was only really going to do a quick little look over this thing and see if it actually worked. I weren't actually intending to tear it all down like this and do a restoration of it, but that's how these things go. So yeah, I'm going to leave it there for now. Like I said, in the next video we'll perhaps have a look at cleaning this case up as best we can, and then we'll have a look at changing some of these bag capacitors, and hopefully putting this thing back together and see if it perhaps does more than it was doing before. I mean, it could still be dead. We could perhaps even try testing some of these transistors, make sure some of these transistors are still okay, because there is quite a little bit of corrosion around here. But yeah, I'll leave it there for now. So I hope you enjoyed that little video on this old gamma tester. So thanks for watching, and goodbye.